Hey everyone, welcome back to the channel. It's your host Dan, and in this exciting new episode, we're diving deeper into the world of Pydantic with some really cool features you might not know about. But if you're new to Pydantic and need a refresher on the basics, be sure to check out my previous video where we covered everything you need to get started. All right, coders. Today we're focusing on two powerful tools in Pydantic's arsenal: fields and validators. These features can significantly improve your code's efficiency and readability. Let's jump in and see how they can take your coding skills to the next level. Just a quick heads up before we dive in. All the code we'll be working with today is available on GitHub, so you can follow along and code with me. The link is down in the description below. To get started, make sure you have the dependencies installed. If you haven't already, open up your terminal and run the command poetry install in your project directory. This will install all the necessary libraries we need for today's coding adventure. If you're new to poetry and need a refresher on how to set up your Python dev environment, there's a whole video on my channel dedicated to that. Just check the description for the link. All right, with that out of the way, let's get coding. Okay, coders, first on the agenda today is the default factory feature. This little gem lets you define a function that automatically generates default values for your Pydantic fields. Pretty handy for keeping your code clean and avoiding repetitive assignments. Let's take a quick look at the tools we'll need for today's Pydantic adventure. First up, we'll be using the datetime module to generate timestamps for our data. The annotated class comes in next, allowing us to add some extra information to our type hints. Finally, we'll leverage universally unique identifier to create unique random ID strings. We'll be relying on some core Pydantic building blocks. First up, we've got the base model class. This is kind of like the starting point for all our Pydantic models, giving us a bunch of useful features out of the box. The other one is the field class. Think of this as a way to add extra details to specific fields in our models. Now we will define our default factories. We'll have one function to create unique hexadecimal strings, kind of like those fancy codes you see online. The other one will help us generate timestamps to keep track of when things happen in our code. Today, we're building a transaction model to handle things like IDs, timestamps, and amounts. The annotated class lets us add extra information, or metadata, to the fields of our Pydantic model. The field class has a built-in mechanism for setting this metadata. We assign the specific generator to the corresponding field. The ID field receives the ID generator, and the timestamp field receives the timestamp generator. This approach enables the code to treat these fields differently based on the attached metadata. Our code can now create a new transaction simply by providing the amount. That's it. The system automatically generates a unique ID and captures the current timestamp for the transaction. This approach keeps our code clean and avoids repetitive tasks. All right, let's move on to the next code example. This one dives into a concept called aliasing. It's a helpful technique, especially when you're interacting with external systems like APIs and databases. You'll see why aliasing is so handy in a bit. The Pydantic field class offers two types of aliases: validation and serialization. The validation alias helps us handle incoming data from external systems, while the serialization alias tailors data going out to those systems. This can be super useful for ensuring compatibility and clarity when working with external sources. Let's reuse the transaction model for this example, but this time, we'll add some twists with aliases. We'll give the ID field a validation alias named transaction ID. This means external systems sending data can use transaction ID instead of ID for validation. On the other hand, the timestamp field will get a serialization alias called createdAt. This way, when we send data out, it uses the createdAt label for clarity. Pretty neat, right? Building on our transaction model, let's create a new transaction. This time, we'll use the transaction ID label when providing the data. That's because we assigned a validation alias with that name to the ID field. Now, if we try to serialize this model, you'll see the timestamp field uses the alias created at instead. This keeps our external communication clear and consistent. Pretty cool, right? Aliases in Pydantic act like magic bridges between your code and external systems. You can keep your data model clean and untouched, while still seamlessly interacting with those systems. All you need to do is redefine how incoming and outgoing data is labeled using validation and serialization aliases. This saves you time and effort and keeps your code focused on the core logic. Okay, moving on to the next feature. We'll explore now computed fields in Pydantic. These are special fields that are calculated based on other fields in your model. The cool thing is, you can include them directly when interacting with external systems like APIs or databases. This makes your models more flexible and data-rich. Let's revisit our transaction model. We'll need to import one more thing from Pydantic, the computed field decorator. This is what allows us to create fields that are calculated based on other data in the model. Imagine we want to automatically calculate a fee based on the transaction amount. Since this fee directly depends on the amount, we can define it as a computed field within our transaction model. Let's create another transaction. When we serialize it, the calculated fee, which we define as a computed field, will be included alongside the original data you provided. This means you get the benefit of having the fee automatically calculated and readily available without any additional work. All right, let's move on to another powerful feature of Pydantic: field validators. These allow you to add even more checks to your data beyond the basic type checks that Pydantic already performs. Think of it like an extra layer of security. You can define these validators to run before or after the type validation. But typically, after validation is the more common approach. Here we'll demonstrate the power of after validator, which runs after the type check. This is handy because you can be confident the data is already the expected type. Let's stick with our transaction model and import the after validator class from Pydantic. We create a validation function that ensures a value is always positive. If it's not, we'll raise an assertion error. Let's take a look at how to use the after validator in our transaction model. We'll use the annotated class to assign this validator specifically to the amount field. This ensures that our validation logic runs every time a new transaction is created, guaranteeing that the amount is always positive and our data stays clean. All right, let's see this validator in action. We'll try creating a new transaction, but this time with a negative amount. Since we've added the after validator, Pydantic will catch this and raise a validation error. This error will tell us exactly what's wrong. The transaction amount cannot be negative. Pretty cool, right? This shows how powerful field validators can be. You can define various checks to ensure your data meets your specific requirements, keeping everything nice and clean. Pydantic offers a wide range of built-in validators you can explore in their documentation. These validators can handle common checks like minimum or maximum values, email formats, and more. By now, you should have a good understanding of how field validators work in Pydantic. They provide a powerful way to ensure your data meets your exact requirements, keeping your code clean and your data reliable. Let's move on to the last example for today and see what else Pydantic has to offer. We will explore now model validators in Pydantic. Unlike field validators, which focus on individual fields, model validators can check relationships between multiple fields at once. Sticking with our transaction example, we'll need to import the model validator decorator from Pydantic. This will allow us to create validations that consider the entire transaction data, not just isolated fields. Let's expand our transaction model to include two new fields, payer ID and payee ID. This will allow us to track who initiated the transaction and who received it. Now, here's where model validators come in. We can define a validator that ensures the payer and payee cannot be the same person. Remember, model validators can run before or after type validation. But in this case, after validation makes the most sense. This way we can be confident both IDs are already of the expected type. All right, let's put this model validator to the test. We'll try creating a new transaction, but this time with the payer ID and payee ID set to the same value. Since we've added the model validator, Pydantic will catch this and raise a validation error. The error will tell us that the payer and payee cannot be the same person. This is exactly what we want. This demonstrates the power of model validators. They allow you to define complex validation logic that spans multiple fields in your model, ensuring your data adheres to your specific business rules. This keeps your data clean and consistent, preventing errors down the line. All right, that's all we have for today on Pydantic. We explored some of its powerful features like default factories, aliases, computed fields, and field and model validators to ensure clean and consistent data. I hope you found this episode helpful. If you did, be sure to leave a thumbs up and subscribe for more. See you next time.